Hey, Geometry Geniuses, for this first section of Chapter 10, check you out. We'll be taking a look at the area of parallelograms and triangles. Quick little agenda for this video. We'll be first finding an area in the real world, taking a look at my house and something that, I don't know, I'm just going to take the area of something in here. We'll take a look at some parallelogram examples where that area is just simply base times height. Then we'll conclude with triangle examples. Do you remember that formula from way back when? Area of a triangle? Fingers crossed, you should be saying 1/2 base times height, where the two are multiplying. Let's get started on finding this area in the real world. So what we've got here is my little office. I've got a dry erase board, my piano set up. I'm wearing Stan socks. Pretty cool, right? I've got these pictures up here, and I'm just going to see with this app if I can take the area of this map of South Philly. So I'm measuring a base just for the top, really. I could have used the bottom base there too. So I have my base here, which is 23.5 inches, which is hopefully about right. You can never really tell with these apps. And let's go for that height. Let's take it from the top all the way to the down. So what's interesting about this app is that, sometimes it's a little wonky. There are tons of apps out there that do the same thing. But what's interesting about this one is that sometimes we get some areas that are three-dimensional or some sides that are three-dimensional. So let's try this one more time. So I'm trying to find the area of this. I know my base is going to be 23.5. My height should be approximately 18 inches or so. So if I had to find the area of this, I would do something like 23.5 multiplying with our height, which was 17 and so 17 and then 9. So you could write this as like 17.75 inches. And if you multiply the two, that would give you the area. So how much area this picture would cover? Approximately. Sometimes these apps are, now look at it. Like the measurements are all over the place. So sometimes these apps are a little wonky, but this was a quick way of how area could be found in the real world. If you were hanging up a painting or a poster or anything like that, everything that you decide you want to hang up covers some area. So that's why this section's pretty important. So that we don't buy something that's too big or too small. So same as it ever was, area for a parallelogram is going to be our base times our height. Some vocab here, seen again, we see altitude. Let's read this off. If we have a base of a parallelogram, that can be any one of its sides, because seen here, our base we normally just denote as this bottom, and the altitude is the normal height. But notice that if we switch this up a little bit, and if we have our base now as this side, our altitude would now be this side length over here, which can be a little tough to figure out or to see, but if you rotate this and kind of put this on your side, like on its side, you'll see that it makes sense that that altitude is the altitude given this base, even though the base is on its side. So let's see what's up with this example. We're finding the area of this parallelogram. I have a base of 5. I have an altitude, pretty easy to spot, of 4. So I would take 5 inches for my base, and I would multiply that with 4 inches, which in this case would be the altitude. Multiplying the two together, 5 times 4 gets you 20. Using units, we would have inches being squared. Boom. And that's how much area this parallelogram covers. Let's keep this going. We can then come across some situations that are a bit more challenging. So let's read this off. This is asking us for the height that corresponds to the 9.4 inch base in the parallelogram seen here. So notice that we have this base of 9.4, and we're trying to get this altitude seen here from D to E. So D to E we don't know, but that's okay. Is there another way that we could get a hold of this area? Instead of just taking this 9.4, multiplying it with DE, is there another way? Well, we know that if we were to take AD, we could treat this as a base, and then treat this 9 as if it's the altitude. So if we took AD and multiplied it with FC, that would still give us our area. So if we plug in some numbers there, A to D is 13. FC, so now this 9 is our altitude for the base of 13, so it's kind of as if we're borrowing it for this case. So if we have 9 times 13, that's going to be how much? 117 inches squared. That's cool. But remember, what are we trying to solve here? We're trying to get DE. So we know that if we had 9.4, and if we were to multiply that with DE, that should get us back to 117, right? And that's true. So if we were to divide both sides by 9.4, taking 117, dividing it by 9.4, let the calculator take care of that. So I was doing 117 divided with 9.4. This is saying that our altitude is going to be approximately 12.45, which makes sense. So our altitude in this case, D to E, is approximately 12.45 inches. Cool. If we take this further, as we continue to take the area with a triangle, really the only thing that changes up here is that we're multiplying now the base and the height by this 1/2 seen here. Some key vocabulary, but honestly not too different than what we saw with the parallelogram, where we have a base of a triangle that could be any of its sides. It really depends on how the triangle is handed to us or drawn out. The corresponding height is the length of the altitude, so this first one's pretty easy to spot that. Our base goes from left to right, and the height goes straight up. Although it's just written here on the left, another way this could be expressed is on the right, just looking like this, just vertical line that goes up. So in this case, our base is pretty easy to spot as 1 foot, and our height is in inches, 5 inches to be exact. So what do you think is the best way to go about this problem, in inches or feet? Hopefully you're saying in inches. So let's convert this base to inches. So this could be our base now of 12 inches. Don't forget the 1/2 at the beginning, because we're taking half of this product. So 1/2 times our base, and then multiplying now with our height. Personally, I like to multiply the base and the height first. So 5 times that 12 would get us 60. And then if we take 1/2 times that, this gets us 30 inches squared for our area of this first triangle. Nothing too crazy here. As we move towards the second one, this is a common problem that I see on SAT practice, where we're given a ratio of a triangle. And I believe we've seen this before just with angles, but In this triangle, we have a base and a corresponding height in the ratio of 2 to 1. The area in this case is 49 inches squared, and we're being asked to find the base and the height for this triangle. So personally, I sketch out these types of situations if nothing's given to me. So they don't say anything about working with a right triangle or an equilateral triangle. So I'll just draw a right triangle to make it simple to see what our altitude is. So they say that we're in the ratio of 2 to 1 with the base. So personally, I use x in this case whenever we're working with a ratio problem, because the base should be 2 versions of some number, which leaves our height to just be 1 version of that number, so just 1x. And we know that the area of this is 49 inches squared. So if we set up our area for this triangle, we know it's going to be 1/2 times our base of 2x times our height of x, and this should be equal to our area of 49. So if we multiply the 2x and the x, that gets us 2x squared. Don't forget the 1/2 at the beginning. 1/2 times this 2 would just leave us with 1x squared equals 49. How can we take this further? What do you think? We can then take the square root. Square root of 49 is just going to be 7. But are we done this problem yet? Nope, we can take this further. So we know that the height in this case is going to be 7. If we plug in 7 here and take 2 versions of it to get our base, this is going to be 14 inches for our base. Simple. Hope that this video was helpful. If you have any questions that come up, please reach out. Thanks for watching.